Okay. Hi, everybody. This is the Team Viceverse AI, and we are working on automating clinical documentation, a Gen AI approach. In today's healthcare world, next slide, please. Meet Dr. Spring, who is frustrated and burned out at the end of the day because he has loads of paperwork piled up on his desk and documentation to be caught up. Plus, he has a child to be picked up after school, and he has some few errands to run at the end of the day. Next slide, please. In today's healthcare landscape, a significant challenge persists: the overwhelming burden of clinical documentation. A recent 2023 AMIA survey highlighted that 70% of clinicians cite this burden as a major contributor to burnout. The same report sadly indicates that physicians often spend more time on charting and paperwork than providing direct patient care. This inefficiency with the EHR not only frustrates healthcare professionals, but also impact the quality of patient interaction. This growing dissatisfaction underscores the urgent need for a smarter and more efficient solution. The core problem we are trying to solve, next slide, please. The core problem we are trying to solve is a time-consuming and often error-prone nature of manual documentation, which directly detracts from valuable patient-physician interaction. Our AI-powered system offers a compelling solution by aiming to significantly reduce the documentation workload for healthcare professionals, deliver faster and more accurate clinical records, generate a structured outputs that are fully compatible with the existing EHR. Imagine a physician conducting a patient interview. Instead of spending valuable time after the consultation meticulously typing notes, our system listens to the conversation, intelligently extracts the relevant medical information, and automatically generates structured FHIR compliant records and SOAP summaries. This frees up physicians' time, allowing more focused patient care, potentially reducing burnout and improving overall efficiency. Next slide, please.
I will take over. So let us now understand the system workflow of how we are going from audio to a FHIR record. Next slide, please. Yes. So let us understand using a workflow diagram. So we have a start node there. We need actually the three inputs from the user in order to achieve our goal. The first input we need is the prompt, which states like which form needs to be filled. Is the prompt is generated by the doctor. So the other two inputs are the patient history, EMR, and the audio recording. We first use the prompt to actually check for the form availability and the questionnaire availability. We pass it to the AI model. It checks our database to check if there is a questionnaire available. If the question is not available, it gives it the error handling happens and the flows end. But if we fetch the questionnaire, then the that questionnaire is mixed. It's contributed with the patient history and the audio recording, and all the three inputs are passed on with the AI model, which gives us the SOAP note summarization, questionnaire response. These two are then passed on to the evaluation agent, which evaluates the correctness of the SOAP note and the questionnaire response on the basis of the inputs given. The SOAP note is also then converted into a binary format, and we use a document reference to actually index it. And this binary format is the format that is stored into the FHIR server. At the end, we are with the four outputs. That is the SOAP note, binary resource output, the evaluation, and the questionnaire response. Next slide, please. Let us understand the core technologies. So first of all, we are using the HL7 FHIR standard to actually handle the data exchange and compatibility with the modern health IT. The key FHIR resources that are used are questionnaire response, binary, and document reference. The benefits that we get are it enables the seamless integration with FHIR compliant EHRs and other systems. This supports both structured data and narrative summaries. Next slide, please. Thus, core technologies also includes the SOAP format of these patient summarization. It includes the subjective, objective assessment, and the plan. This format is passed on as a prompt to the AI, which gives us the output in a proper SOAP format. And for the whole project to be possible, we are using the Gen AI capabilities. We are actually using the Gemini family of the Google as our powering model. It not only helps in the transcription, natural language understanding, response generation, but it also helps us in the summarization and the evaluation part, which are very key for saving the time of the doctors. Next slide, please. This is the technical graph which explains the major functions that we have used in the code. This includes uploading the audio files to the server, using them, then evaluating them and using them to generate the SOAP response, the questionnaire response, and then using the evaluator to evaluate the responses. And also at the end, we aggregate all the outputs and write out the responses in a text format in the notebook. Next slide, please. Now let us understand a little about the data also. So data set that we are using is a patient-physician interview. It is a simulated encounter, and the audio that we have is mainly focused on the respiratory diseases. There are certain pros and cons of it. The pros includes it avoids the real patient data, which with like controlled training environment, and the cons include the lack of realism. It is because the audio that we have is too much clean. It might overlook the possibility of noise, interruptions, accents, and non-scripted dialogues. There is also a con of limited scope, as we are only having the audio that is more focused on the respiratory disease, which might limit generalizability to other specialties. And due to the poor generalizability, the performance on real-world audio may be significantly lower, which can create a critical validation gap. Next slide, please. So this slide actually explains the three cases that we are handling for the real that are happening in the code. The first error for the three cases includes the success. First case is the success case, in which like we try to find the questionnaire that the doctor wants to fill, and we found that questionnaire into the database. Right. So that can help us to generate the questionnaire response, generate the SOAP summary, and also convert all this into the binary format and the correct format to which can be uploaded to the FHIS server. But there might also be a case where the questionnaire is not found. In that case, our code handles the part and it skips the questionnaire response generation, but it continues with the SOAP summary generation, which is then converted to the binary format, and the user is notified with a partial success. There might also be a case in which the questionnaire response is totally invalid or the request is totally invalid. In that case, the code handles the error with no documentation generation, and the system gives out an error message, user prompt to revise the input. What are the benefits is like we get a clear error feedback, which can enhance the usability. Next slide, please. Yeah, from here, Nikita can explain the challenges.
Thank you, Lakshmi. And coming to challenges, we faced challenges with data access, and we have had data security and privacy concerns too. We have to achieve accuracy in noisy settings, clinical validation, and EHR integration. And if a relevant questionnaire is not present in the database, full structured output cannot be generated. Building trust with clinicians, addressing AI bias, and ensuring scalability were also our key concerns. Despite the challenges, this technology holds immense clinical potential. It can ease administrative burdens, improve workflow efficiency, and unlock meaningful data for research and decision making. Our next step is real world validation, like testing on actual clinical audio and ensuring the system is accurate, safe, and easy for clinicians to adopt. This is a scalable, forward thinking solution that blends generative AI with healthcare interoperability. What lies ahead is bridging the gap between the simulation, and real world use. And this project was built by a team of four: Hari, Lakshay, Peter, and myself, each contributing our strengths to create a solution we are truly proud of. And these were the references we have taken. And thank you.